Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 6 from the January 2024 Pure Mathematics P3 International A-Level Edexcel exam. And here we have a question about this curve. It says, figure 1 shows a sketch of the curve with equation y equals f of x. It says where f of x is equal to 2 times e to the power of 3 sine x times cosine x, and x is between 0 and 2 pi. The curve intersects the x-axis at the point R as shown in figure 1. Okay, state the coordinates of R. So this curve actually intersects the x-axis at 2 points. There's a point here and there's a point R. Okay, so that's something we need to keep in mind. So first of all, R is on the x-axis. Okay, so R is on the x-axis. Now what we know is on the x-axis, y is equal to 0. So if you want to find where something crosses the x-axis, you must replace the y with 0. So we have to solve the equation 2 times e to the power of 3 sine x times cosine x equals 0. So this means you have like here a product of two factors. You have 2 e to the power of 3 sine x equals 0. So either this is equal to 0, or you have cosine x equals 0. Now, for this, there will be no value. E to the power of something will never be 0. Okay? E to the power of something will never be 0 because it's always going to be something which is it's an exponential curve. It will never touch the x-axis. Right? So there's no solution to this part of the equation. However, cosine x does equal 0. Now, the principal solution, if we say inverse cosine of 0, and here, of course, we're dealing with radians. So the inverse cosine of x, inverse cosine of 0, the inverse cosine of 0, that's going to give you pi over 2 radians. Okay? That's the principal solution. Now, between 0 and 360, between 0 and 2 pi, there's going to be another solution as well. And for the cosine curve, it's always 2 pi minus the angle that we got for the principal solution. So it's going to be 2 pi minus pi over 2, which is 3 pi over 2. Now, which of these is going to be the coordinates of the point R? Well, this is the first positive solution, which is going to be this over here. This is going to be the pi over 2. And the next time where it hits the x-axis is going to be at R, which is 3 pi over 2. Okay, so we can see here very clearly that the coordinates of R are going to be 3 pi over 2 and 0. It says state because you don't really need to show that much work for this. You know it's when cosine x equals 0, and we should all know that that's when, x is pi over 2. And we should also understand that between 0 and 2 pi, there are two places where cosine of x is going to equal 0. One is at pi over 2, and the other one is at 3 pi over 2, which is found by understanding that the cosine curve, it's going to have two places where it shares the same cosine ratio. So we're finding where cosine x equals 0, pi over 2, and 3 pi over 2, and 3 pi over 2 is the one that we need for R. Okay, so I hope that's clear, right? Even though this is not the cosine curve, it's the solutions to this equation will give us the places where this curve hits the x-axis, because it's part of the solution to the original equation, which is of this particular function. Right? So that's something that we need to understand. Right, for part B, it says the curve has two turning points P and Q as shown in figure 1. P and Q. Show that at points P and Q that this equation will be, this is the equation that's formed when you try to find the coordinates of P and Q. Okay, if you solve this equation, it will tell you the coordinates of P and Q. So how do we form this equation? Well, we know that the turning points, the turning points of a function are where the gradient is equal to 0. Okay, so where f dash of x is equal to 0 at the turning points. That's always the case. So we know that f of x is given by this function here. Okay, that's f of x. So we got to find f dash of x. And here we have two separate functions multiplied by each other. Okay, so we have e to the power 2 e to the power 3 sine x and cosine x. They are two functions which are not related to each other. Okay, so we have to use, it's not like a function inside another function. All right, so we have to use the product rule. So we can call one of them u. So I'm going to call 2e to the power of 3 sine x as u, and v is going to be cosine x. So when I find the differential of u dash, that's going to be basically where you have to differentiate something of the form e to the power of something. Now, when you differentiate something of the form e to the power of something, it stays the same. Like if I differentiate e to the power of x, it's going to stay as e to the power of x. However, if I have e to the power, for example, 4x, it stays as e to the power of 4x, but then I have to multiply by the differential of what's inside the function, which is 4. So similarly here, if I differentiate this, initially you can say it stays as 2e to the power of 3 sine x. But then I have to multiply by the differential of what's inside the function. Now, if you differentiate 3 sine x, you get 3 cosine x. Okay? And v dash is going to be just basically, if you differentiate cosine x, you get negative sine x. Remember, differentiating sine x gives you cosine x. Differentiating cosine x gives you negative sine x. We have to remember that. So not in the formula sheet, so you have to know that. So this u dash x will end up giving us 6 times e to the power of 3 sine x times cosine x. So when we want to now use the product rule, I'm going to multiply these together and multiply those together and add them together. And it doesn't matter which order you do. I like to use this order, start with this one, because that's what we do with the quotient rule, and I like it to be like, you know, kind of standard what I do in both cases, the same kind of order so you don't get mixed up. So I'm going to multiply these together. So I'll have 6 e to the power of 3 sine x times cosine x, which would be cosine squared x, plus, and then these two multiplied, which is going to give me, in fact, it's going to become a minus because I'm multiplying by a minus number. So it will be minus 2 e to the power of 3 sine x times sine x. Okay, I'll just put the minus on the outside there. So this is f dash of x. This is f dash of x. Okay, so this is the gradient function. And we know that at the turning points, f dash of x equals 0 at P and Q. Okay, so we're going to now equate this to 0. Okay, so we have 6e to the power of 3 sine x times cosine squared x minus 2e to the power of 3 sine x times sine x equals 0. So what's a common factor in these two terms? Well, from the numbers, there's 2. From the e terms, there's e to the power of 3 sine x. And then you've got inside the bracket 2 times, you have to end up with this. So 2 times 3 cosine squared x minus, that's the same as it is there. So you just minus sine x is equal to 0. So this will give you 6 e to the power of 3 sine x cosine squared x. And this will give you minus 2 e to the power of 3 sine x times sine x. Okay, so this is the factorized form of this. So to solve this equation, either this part is equal to 0, which of course it can't be because e to the power of something can't be 0, so there's no solution to that part. Or we can say 3 cosine squared x minus sine x equals 0. Now what we have to show is a sine squared x plus b sine x plus c equals 0. So basically, the cosine squared x has to be replaced and written in terms of sine squared x. And we know we can do that because of our identity. Sine squared x plus cosine squared x equals 1. So we can say the cosine squared of x equals 1 minus the sine squared of x. So this is going to be 3 times 1 minus sine squared x minus sine x equals 0. So you have 3 minus 3 sine squared x minus sine x equals 0. So we want to put it into the form like this, where a, b, and c are integers to be found, and c Yep. So what we'll do is I'll make it so that the sine squared x is positive to make life a bit more simpler for later on. So I'll multiply everything by -1, in which case I get 3 sine squared x plus sine x minus 3 equals 0. So that's the form that we have to write it in. And that completes question number 6, part B. Okay, so now for part C, it says, hence, using what we just did means, find the x-coordinate of the point Q, giving your answer to 3 decimal places. Okay, so now, we have to solve this equation first. That's the first step. So we have 3 sine squared x plus sine x minus 3 equals 0. To make things a bit more familiar, like a lot of times students like to do, when you have something like a disguised quadratic like this, let u equals, for example, sine x, sorry. Let u equals sine x. So this will be 3u squared plus u minus 3 equals 0. Now, we want to try to factorize this first if we can. Now, if we try to factorize this, we'll see you're going to have two numbers multiplied to give you -9, because you have to multiply these two together, and add to give you 1. Now, I don't think there's any numbers that do that. To get 9, you have 9 and 1, 3 and 3. None of them have a difference of 1. So it looks like we cannot factorize this. We could complete the square, but that's going to be a bit messy here because you're going to have this fraction in this part. So I think the easiest thing for us to do here would be to use a quadratic formula. So I'm going to use a quadratic formula, and if we know the quadratic formula, you'll say x equals minus b plus or minus the square root of b squared minus 4ac over 2a. You don't get any marks for quoting the formula, but you do get marks for putting things in the right place. So in this case, our a is going to be 3, the coefficient of the squared term. Our b is going to be 1, the coefficient of the term to the power of 1. And the constant term is your c. So you have b, you have minus b, so it's going to be -1 plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which is 3, times minus 3 all over 2a, 2 times 3. So very important that you show that you've put everything in the right place. Don't just write the answers down from your calculator. You must show your steps here. So you have -1 plus or minus the square root of. So you're going to have 1 plus, that's 4 times 3, which is 12, times 3, which is 36. That's going to be 37 all over 6. Let's just make sure that's right in case I've done something silly here. So you have -1. Let me put in the brackets. You have -1 plus the square root of 1 squared minus 4 times 3 times -3 all over 6. So that gives you -1 plus or minus root 37 over 6. So therefore we can say u is equal to either -1 plus root 37 over 6 or -1 minus root 37 all over 6. So those are the two possible values for u, which means those are the two possible values for sine x. So you have sine x equals -1 plus root 37 over 6, or sine x equals -1 minus root 37 over 6. Okay, so let's see what solutions these bring. All right, so if I use this one first and I press, now we're going to be here in of course radian mode, okay, because our angles were in radians, and plus when you differentiate, when you've used differentiation calculus with trig functions, you must always use radians. Okay, so that's very important for us to understand. So we have minus, let me just store this answer as a in case I need it again. So yeah, we have this, so we're going to have inverse sine of the answer. We are in radian mode, yes we are. So we press equals. That gives us x equals 1.010555. X equals 1.0105. Like this goes on. Okay, so that's one solution. Let's see what happens to this. Okay, I'm going to store this answer as b So I've got that answer if I need to use it. But let me go back to this here and change this. One second. All right. I'm going to change this for a minus sign. Okay. And I'm going to press inverse sine of this. I myself think this is going to give us something that might not be giving us any answers because it might be less than -1 its value. Yes. So you see that this value is going to give us something less than -1. Okay. If I find the value of that, find the value of that, it's something less than -1. Okay. And the sine curve can only have values between -1 and +1. So this is out of the range of the sine curve, so there will be no solution to this. There will be no value of x that gives you this. So here we have x equals no solution. No solutions from this. So we got to concentrate on this. Now, so this is the angle where there's going to be a turning point. Now we can see that there are two turning points here, P and Q, right? Two turning points, P and Q. Now, this turning point here, okay, is obviously going to be the first one. And this one is going to be the second one, all right? Because, you know, the lower angle, to find the second angle, you have to, for sine curve, remember the sine curve, okay? If I want to solve this equation, you know, you have the principal solution, and then you have pi minus the principal solution to give you the other solution for the sine curve. Okay, if you remember for the sine curve, you have the calculator answer and then 180 minus or pi minus that answer to give you the other place where sine x equals that value. Okay, and we know to find P and Q, this has to be satisfied. This equation is satisfied to find P and Q. So the first angle we get to is going to be the one that's got the lower value of x, that must be P. And the second angle we get to must be the high value of x, that must be Q. Okay, so we're going to take our answer that we got, which was this answer over here. Okay, where was it? Let's recall it 1 second. We're going to recall that answer. Okay, that was the answer we got. And we're going to do pi minus the answer. So pi minus the answer, that gives you 2.13103. 2.13103. Okay, so those are the two answers. So you have x equals 1.01055. If you round to 3SF, to 3SF, does the question tell us what to do here? 3 decimal places. Normally it would be 3SF. It didn't say anything. Here they've said 3 decimal places. So we must go to 3 decimal places. So let me get rid of this. Okay, 3 decimal places, 1, 2, 3. So we stop there. So you get 1.011. Okay. And this is going to be 3 decimal places, 2.131. Now this is the x coordinate for Q, and this is the x coordinate for P. Right. So we can say that they want us to give the x coordinate of the point Q. So we can say the x coordinate of the point Q is equal to 2.131. Okay, we don't want the x coordinate of point P, we want the one for Q, which is going to be the second answer that we get to. Okay, so we have to find the principal solution and then do pi minus the principal solution because we're talking about the sine curve. All right, we're talking about the sine curve. All right, and we know that for the sine curve, that, you know, to find the second solution, you do pi minus the principal solution. Those are the two main solutions, and we're looking for the second solution, so x cubed. Now, if you wanted to really, you know, make sure or whatever, you know, you could work out whether P is a maximum or a minimum by using the second differential if you want to, or by using the first differential and putting a value just before this and just before that into it if you want to. Okay, but there's no need to do that here because you can see with your eyes that P is the first turning point and Q is the second turning point. This is x in radians. So you know the lower value of the angle, this is the first positive angle, the lower value of it must be P, and the higher value of it must be Q. Okay, so that's something that's important for you to understand, okay, in these type of questions. All right, so they're asking for the higher value of the turning point, which is Q, which is 2.131. Okay, there's no need for us to try to find the second differential of, what we differentiated and then substitute the value in. That's a bit of a bigger hassle, because look at the expression that we're going to get to. We're going to have to differentiate this again. What a hassle it will be, okay, to find the second differential. I mean, we could use the first differential and substitute a value just before the turning point and just after the turning point to verify that it's going to be, going like this and then like this, all right, negative gradient, then positive gradient. But again, that's a lot of hassle. It's much, much easier to just solve the equation and understand that the first solution is going to be the maximum and the second solution is going to be the minimum, because the maximum comes before the minimum. Okay, so that hopefully explains part C. I think that's the end of the question. So there we have question number 6 from the January 2024 Pure Mathematics P3 paper done. Any other questions from this paper that you would like to see? You'll find them in the playlist that will appear in the top right corner of the screen at the end of the video. You'll find other questions dealing with, I guess it's differentiation from P3, and also I'll put trig, identities and equations. I'll put 2 playlists that will be relevant to this question, and you can watch a video which will show you how to use my channel to find things that might be useful for you. Thank you for watching, and see you soon.